Hello everyone, my name is Justin Marinac, mechanical engineer with Geo. We are a collection of companies that specialize in geothermal engineering and construction. My background is in HVAC design with emphasis on geothermal heating and cooling technologies. Today we're going to be talking about geothermal heating and cooling systems here in Florida. To begin, we will mention there are several types of geothermal systems. They include closed loop, which is composed of closed loop piping system of water run in the ground. The piping can be both horizontal or vertical. Open loop, which will be the focus of today's presentation, these systems transfer heat to and from water that is pumped out of the ground. There are also standing column, which are deep wells that contain a large column of water, as well as surface water exchangers, which transfer heat into and out of bodies of water. There are also other types of technologies that specialize using different compounds, such as CO2. The factors that determine the type of geothermal to be used, they are the building's heating and cooling loads, the climate in which the buildings are located, the process for which the geothermal is needed, whether it's heating and cooling, generating electricity, or other special processes. The ground for the heat transfer also plays a role in the type of geothermal used, as well as the available space on the surface. The project we're looking at is the Pinellas County Safety Complex. This building functions as a Sheriff's Administration building and Emergency Operations Center. It is classified as a COPS building, which means Critical Operations Power Systems. The building served by the geothermal system is nearly 300,000 square feet in size. It requires 24/7 continuous operation and functions for emergencies. There is a potential of 1,000 tons of heat rejection for the geothermal system. For reference, a typical home is 3 to 4 tons of heat rejection or air conditioning. Typical chilled water plant. Typical systems for buildings like this use water-cooled chillers with cooling towers. The building on the left rejects its heat to chilled water produced by the chiller. It uses a Carnot refrigeration cycle to extract heat from a space and put it in hotter areas. That heat is then rejected to a cooling tower that evaporates water to create a cooling effect. This process uses energy and consumes water to provide the cooling. A chilled water plant utilizing geothermal. This facility was originally designed with cooling towers. However, during construction, the design team made a change to geothermal. As you can see, the geothermal wells and heat exchangers replace the cooling tower. There is no water consumption for this cooling method. All of the water is returned to the ground. So how a geothermal system is constructed, we need to look at the ground in our area. First, we have the land surface. Below that, the superficial layer, which is 50 feet deep and composed mainly of sand and shell. Next is the confining layer, which is made of clay and separates the superficial layer from the aquifer itself. It helps keep the aquifer relatively clean and protected. There are several layers below that, including other confining layers and other aquifers, some with saltier water. To begin construction, we need to drill a supply well. This well extends from the surface down through the layers and penetrates the aquifer at about 100 to 200 feet deep. It is composed of steel casing and is grouted to prevent intrusion from above. The wells can produce more than 1,000 gallons of water per minute. The wellheads contain various fittings and gauges for monitoring the system. It also includes electrical disconnects for the submersible pump down in the well that pumps the water out. These wells are permitted by Southwest Florida Water Management District. Here's a photo of a supply wellhead. You'll notice that there is an electrical disconnect for the submersible pump. The next component is the return well. These are constructed similarly to supply wells. However, they do not have a pump. 100% of the water pumped out of the supply well is returned to the aquifer, a few degrees warmer. These particular wells are spaced more than 1,000 feet from one another. Distance helps to prevent short-circuiting of the water. These wells are permitted by the Florida Department of Environmental Protection. This is one of the return wells. Notice there are valves and gauges, but no electrical disconnect. Between the two wells is a central energy plant, which houses the chillers and heat exchanger. The heat exchangers are plate and frame type. They are composed of stainless steel plates that have channels between, allowing two different water streams to transfer heat without touching. This is where the building heat is transferred to the groundwater. Here are some photos of heat exchangers in a central energy plant. Notice how little space they take up, especially compared to that of a cooling tower. To complete the loop, we need to connect the wells to the central plant. This is typically done via high-density polyethylene pipe. It is fusion welded and has a buried service life of 50 to 100 plus years. The public safety complex only uses geothermal for cooling. You can see the heat from the chiller is brought down through the heat exchanger and cooled down and returned to the chiller. The 81-degree groundwater absorbs the heat and then is returned to the ground. From an efficiency standpoint, compare this to an air-cooled chiller, which has to reject its heat to 95-degree plus hot summer air. These systems can also be used for heating in a similar method. Instead of chillers in a plant, you would need heat pumps that can reverse the flow of refrigerant in their systems. In this case, the plant equipment would absorb heat from the ground and inject it back a few degrees cooler. Thermal energy networks. This diagram shows how this technology can be scaled to maximize effectiveness. Multiple buildings can be networked together on a loop and share energy with one another. The geothermal wells can be used to balance the temperatures in the loop. The more varied the building type, the more effective the energy sharing will be. Tax credits. Additionally, these types of systems are available for investment tax credits. Certain criteria has to be met for different percentages. They include using geothermal technology, paying prevailing wages, using domestic content, among others. Credits can vary from 6% to 40% of the total system cost. The key takeaways. Our aquifer is a consistent temperature year-round at 82 degrees. These systems do not consume any water. All the water is returned to the aquifer. These systems can handle almost any size heating and cooling load. They can be designed for new construction or retrofitted on existing systems. They work for any building type, even special cases like critical facilities. Well, that's all we have for you. We hope you enjoyed this presentation. Thank you.